Ladies and gentlemen, hello. It's been a while since I did one of these coding videos, and today's daily LeetCode video is problem 237, delete node in a linked list. My timer says 000. I really hope this is recording. Okay, so there is a singly linked list head and we want to delete a node in it. You're given the node to be deleted node. You will not be given access to the first node of head. All the values of the linked list are unique and it is guaranteed that the given node is not the last node in the linked list. Okay, that part is very important. We're going to understand why later. So delete the given node and blah, 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 blah. Note that by deleting the node, we do not mean removing it from memory. All right. All right, so basically, this is a tricky question because they give you a node and that's all they give you. They give you a node in a linked list and they expect you to delete the node without being able to backtrack and reassign the next value. So to put it into words is we cannot reassign the next value of the previous node to easily delete the node, right? So we are expected to delete this node without reassigning the next value. So how do we do that? Well, if we can't reassign the next value and we only have the nodes that come after this node, then we can simply edit the node's value to the next node's value, and every node that comes after the node to be deleted will have its value changed to the next value. So like in example 1, right, we're given the 5 node and we need to delete this node, right? So instead of changing 4's next value, we could just reassign 5. We could reassign 5's value to 1 and we'll change 1's value to 9, and then we will make 9's next to none, so we'll get this, right? So 4 points to 5. This is 5. And we are just going to change the value to 1. And 5 used to point to 1. And we're just going to change 1's value to 9 because 9 came after 1. I hope that makes sense. I tried to explain it the best I can. Or let's take a look at example 2, right? So we're given 1. We just have to change 1's value to 9. Right, so we'll change this into a 9, and then we will reassign 1's next to none so we could get this, right? I think it will make more sense when I code it out. So the runtime of this will be O of n, and the space is O of 1. We don't use any extra space, and in the worst case scenario, the given node is the head, so we would have to reassign every node's value. So the runtime would be O of n, and yeah, no extra space. So how we can do this is let's take it one step at a time, right? So if node.next, if there is a node.next, then our current node's value will become node.next's value, and yeah. And we would have to do this in a recursive function, right? So define curl to node, and we will call curl on the node that we're given, right? So we're going to call curl on 5. If 5 has a next, then node's value we become next's value. So 5 will become 1. And then we will call curl on node.next. So we're going to call curl on 1. So it will go down the line and just keep reassigning it'll keep reassigning the values, right? So I'm gonna run the code. It's not gonna work because there is a edge case that we have to handle. And you can see that there is a extra 9 at the end, which is supposed to be none. But okay, so let's try to tackle it like this, right? So if node.next equals none, so when we get to the 9 and node.next is none, then can we just do node.val equals none? Well, that wouldn't work because if we run the code, if we run the code and we try to do it this way, it would say, okay. Well, that's not gonna work. Let me just show you what we can do. So if node.next, node.val equals node.next.val, and then we'll call the curl. But if, so we get to this 9. If node.next.next equals none, then node.next equals none. And then we could return. And that's basically the solution. So it's important because it is guaranteed that the given node is not the last node in the list. So when we get to the second to last node in the list, we can check if we are approaching the end of the list. And if we are, we will change next to none so we don't have that extra node, that extra duplicate node at the end. And that's basically the solution. It's pretty intuitive. I think it's an easy question. And yeah, that's the solution. Thank you for watching. See you in the next one. Peace.